Hello, class. Let's talk about the second method to solve one of these design problems, and we want to figure out which one fails first. My favorite method is actually the assume and check method. The assume and check method, you arbitrarily pick one to fail, and then you go back and check to see if that's actually what's controlling, if that's the point of failure. So here's how I'm going to do it. I'm going to assume that one of these fails. Now, if you already watched the other example, you already know that this one's going to fail first. But I want to show that the assume and check method will work even if we guess wrong. So what I'm going to do is I'm going to guess that TAB fails first. I know that this is wrong, so don't stop the video and stop listening to me. I know that that fails. That's not going to be right. But I want to show you that even if you guess wrong initially, you can then pivot and find the right answer. So this is the assumption. And when we assume, we've always got to go back and check. That's why it's assume and check method. It's not assume and you're done. It's assume and check. So we're going to assume TAB fails first. If it fails first, we can figure out what TAB max is. Now TAB max, the maximum force it could be, is that stress times the area of AB, right? And we could also figure out what it would be for TCD. We'll do that in a sec. Let's do that as well. And these stresses don't tell us which one fails first, but we can use those, those max values, not stresses, the maximum force values to then go back and check against our W max. But let's start with this. Let's figure out what these values are going to be. Now I said the stress is going to be 300 kilopascals. 300 kilopascals times our area. In this particular case, for AB, that would be 10 millimeters squared. Remember, this is millimeters squared, so that's 10 to the negative 6. This is 10 to the third. When I do that, I'm going to get 3,000. That's 3,000, 10 to the negative third pascals divided by area, or times, excuse me, multiplied by area is going to be in newtons. So this would be 3 newtons, because the 10 to the negative third and those 3 zeros would cancel out. Our second calculation here, and I did not give myself enough room, clearly, this is 300 kilopascals times 15 meters squared, and we did this calculation already. That gave us a value of 4.5 newtons, right? These are very, very thin, but fairly strong materials. All right, so now those are our two maximum values. Now, that's not going to tell us our answer. We're not going to assume that both of these are happening, right? That's a bad assumption. We're going to assume TAB fails first. So let's draw a free body diagram. If we know that this is our free body diagram for our object, we said TAB fails first. TAB, we calculated, was 3 kilonewtons. We know this is our bad assumption, but we're going to run with our bad assumption and prove that it's wrong. Then we know that the opposite has to be true. This is TCD, and this is going to be our resultant force. Now, we already did our resultant force calculation. Our resultant force is going to be our length, 1/2 our height times our length. In this particular case, we said our height is unknown. That's the W max times the length. Our length in this case is 6 meters. So this is going to be 3 times W. Remember, W doesn't have units. In the previous example, I guessed kilonewtons per meter. That was wrong. I would say it's probably going to be in newtons per meter based on the length here. But that's 3 times W. Okay. Let's figure out what that W's got to be. Let's take a moment about C. Or we could even take a moment about where FR occurs. Let's do that. That's going to tell us which one fails first. Let's do that. So that point We're going to call it, it's not labeled here, but we're going to call that point E. You know that it's 2 meters here, and it's 4 meters to here. So if we take a moment about E, we don't even need to know what FR is to tell us which one fails first. If we assume that this is at its max and it's failing first, well, we take that, it's going to be 3 kilonewtons times its lever arm, that's going to be negative, times its lever arm, which is 4 meters. And then we got TCD, that's going to be positive, times its lever arm of 2. And that would mean, in this case, if our TAB was actually at failure, TCD would have to be, in this case, 12. Sorry, this is going to be in, it's like kilonewtons. I should say newtons here. I know you're all screaming at your screens, Albert, it's newtons, not kilonewtons. Why are you so fixated on that? I've made the change here, sorry about that. 12 Newton meters divided by 2 meters. That means that this would have to be 6 newtons. 6 newtons is much greater than the max that it could be. Much greater than the max, which means our assumption is wrong. So when I go back, it's wrong. Wrong, I tell you. If that is not true, therefore, we only have one option. Therefore, TCD has got to fail first. Because now that we've proven this wrong, there's only 2 options. One of them fails, the other one fails. Hey, I know that this one is not it. This is not the one that fails. This is not critical. It's not the one that fails. I know that TCD has to be the failure point, and from there I can very simply solve the problem, right? If I go back and change that, I would instead use TCD. TCD is now 3 kilonewtons. Or sorry, yeah, TCD is now TCD is now 4.5 kilonewtons. And by kilonewtons, I mean newtons. And now that I know that that's 4.5 kilonewtons, I could use that to find out what FR is. Well, if using what I know of FR, I could use it to find out what W is. I would have the same answer I got in the previous problem. So same process. I would say this is a little more intuitive because you can figure out what those 2 max values are. And you can use that to make your guess based on how you think the load is distributed. But at the end of the day, it doesn't matter if you guess wrong or right. Once you know which one fails first, you are on the right track and you're close to the answer.